Hello everyone. In this video we're going to learn how to add vectors which are not along the same line and they don't make a 90-degree angle. For example, let's take a y-axis and let's take an x-axis. And let's say I have the following vectors. So I'm going to consider those vectors forces. So the first force F1, let's say it's equal to 5 newtons, making an angle of 45 degrees. And I have another force, F2, 4 newtons. Let me fix it a little bit. So you have F2, 4 newtons, making an angle 30 degrees with the x-axis. So how to add those forces? If you want to add them graphically, it's going to be easy. You just simply continue the parallelogram in this way, something like that, and that will be the F-net, the vector between them. Okay, that's going to be F-net. Let me fix it a little bit, maybe like that. Yeah, that will be F-net. Now, if I would like to find its magnitude and direction, how to do that? Since the angle between the forces is not 90, I need to resolve the forces first, put them along the x and along the y, and then I use Pythagoras and the tangent function. So we'll start with F1. So for F1 now, I will find the x component of F1. F1x is going to be F1 cosine 45 degrees. So it's going to be 5 multiplied by cosine 45, and the answer is 5 times cosine of 45. You will get around 3.5 newtons. F1y, it will be F1 sine of 45. So 5 sine of 45. And it will be 5 times sine of 45. You will get around 3.5 newtons. For sure, same answer, because cosine 45 is same as sine 45. Now let's go to F2. Also, F2x will be F2 cosine the angle, and the angle here is 30 degrees, the angle with the x-axis, cosine 30. So it will be 4 multiplied by cosine of 30. 4 times cosine of 30, you will get 2 radical 3 or 3.46. You round it around 3.5. Around 3.5 newtons. All right, and F2y will be F2 sine 30. So it will be 4 sine 30. 4 multiplied by sine 30, you will get 2. Now, if you look carefully at the figure, the y component of F2 is going to be here. That's the y component of F2. Okay, that's F2y. And from here till here is F2x. So the y component of F2 is along the y-axis, along the negative y-axis. So here you can simply put or write that it's going to be down. This is to the right. We have seen that it's going, F2x is to the right. F1y, if you look back again in the figure, F1y is here, so it's going to be up. Okay, so F1y is going to be up and F1x is to the right. Now, since we find the x and y components, now you add the x alone and the y alone. So Fx will be F1x and F2x. So it's going to be 3.5 plus 3.5, and you will get 7 newtons in that case. Fy, it's going to be 3.5, it's positive, but minus 2 because the 2 is down. So it's going to be 1.5 newtons. 1.5 newtons. Now, since we found Fx and Fy, then I can find Fnet. Fnet will be the square root of f of x squared plus fy squared, fx squared plus fy squared. So it will be a square root of 7 squared plus 1.5 squared. Let's see what we'll get. Square root of 7 squared plus 1.5 squared. You will get 7.15 or 7.2 newtons. That's the magnitude. And the direction, again, theta tangent inverse of Fy over Fx, 1.5 over 7. So tangent inverse of 1.5 over 7, and you will get around 12 degrees above the x-axis, 12 degrees above the x-axis. And we can see that clearly in the figure. That's Fnet, which is equal to 12 newtons, or 7.2, sorry, and the angle is 12 degrees. So that angle here, this angle here is 12 degrees. All right, thank you for watching.